the correct use case. Let's say you're building something, you can build with single linked list as well. But later in the future, if you want to change it, it will be a very big task. So by default, they will start with double linked list and they'll continue, because double linked list is a very simple thing with a better traversal and better optimizations. Optimizations means in the traversals only. So if I'm at the middle point, I can go either this direction or that direction. So it's very convenient. Okay, so there is also another variation of linked list known as, so this we have talked about double linked list. There is also a variation of linked list known as circular linked list. So even this is okay. Even here we have two things: single circular, that means only one link, and then double. So we have seen only the normal one linked list where we have seen single and then double. Just now we have seen double. So now the same was with circular. Circular, the point is once the linked list is created, let's say I'm using circular single. Okay. So once this linked list is created, we will point to the null. Correct. This is for the normal one. But circular, it doesn't happen. There will be no end. Instead, the last element will point to the head again. Okay. So if we maintain this as head, so the last element will point to head. If you're having a double, then the same thing. They will have reverse links. So even this will point to this. So that's the difference between single linked list, double linked list, and circular linked list. So the question is, where do we use circular linked list? So the question to this, circular linked list is used in job sequences algorithm in operating systems when we have round robin scheduling and all those stuff. There we will use circular linked list because there is only if you see there is a processor and the task will come and execute and they will go out. So there should be a continuous flow of tasks. So we need a circle of let's say a task waiting in the queue. So if you maintain a queue like this, it will work, but so it will come, execute and go. It will come, execute and go. But there are few things such as round robin or scheduling. So in this case, we will not. So let's say this is taking 10 seconds. This is a processor. It is taking 10 seconds. It is taking 5 seconds. Okay, so we will in the queue, what will happen is we will have to wait 10 seconds till this thing complete. So only after that this will all the others will start. So to avoid that, there are few scheduling algorithms round robin. So in that case, what will happen is it will go, it will work for 2 seconds, let's say, and then it will come back again. It will go here. So and then the next one will go. So if you see, it is kind of a circular linked list. So it is going and then coming back. So all of them are connected. So in that case, we can use this circular linked list. So basically in scheduling algorithms, we use this. So in real world or for your level, you should be very good with single linked list because all the competitive questions will be on single linked list. And if you are creating any application or if you're doing any side projects and all where you want to implement linked list, then you do go with double linked list. So these two are very important for you. Any questions? Can you explain the difference between single linked list, double and circular? I just explained. Single means it will only have one pointer. Double means it will have two pointers, previous and next. Circular means both the properties are single and double. The only extra property is that the last the last node will point to the head. That's the only difference between these two things. So single linked list, double linked list, circular linked list. It will have one pointer. It will have two pointer. It will again, depending on it, it can have one or two. So I will write it like this: circular single linked list, double circular double linked list. So one pointer, two pointer, one pointer, two pointer. Here one way traversal, that two-way traversal. Here circular traversal. That means there is no end. Okay, if we start traversing, we will just continue into loop. So you should be very careful while traversing the circular linked list. Circular. Okay, and then what? Here there is one extra property, is that last points to head. Last points to head. The same thing. Even in double circular linked list, this will happen. Okay, any confusions now, or are we good here? For problem solving, don't worry about circular, because circular will not come in problem solving. Very rarely they will come. If it comes only, you have to worry about this point, that last points to head. So while traversal, you have to be very careful, because you might go into infinite loop. Why we write the loop like this, like while current is not equal to null. So in that case, current will never be equal to null, because it is pointing to something. So in that case, you have to maintain a visited array or something like that, and you have to do it. Uh, so yeah, and for problem solving, this will have around 80% of problem solving you can find on single linked list, and then the remaining will be on double linked list. So based on these two, you can do it. Okay, so let's see. Let's do a quick implementation of double linked list. We've seen the uh, single linked list, right? Yes, in the previous session. So we will just see the insertion. No, it will not take much time. Okay, so for first thing that we will need is a node class. So node will have two things: data, and again I am writing integer data, but it can be anything. So you can give char, you can give a student data, anything can be given here. Public node next, public node previous. So see, this is the main point. Okay, so we are maintaining a previous pointer. So we should also change our insertion and deletion logic. Uh, we will also have to change the insertion and deletion logic in a way that this previous is updated properly. So now let's have a constructor. So public node uh, int data. So this dot data is equal to data, and then this dot next is equal to null. Yeah, so our class is done. So let's let's create a separate class now for my double linked list. So I will do like this. So in previous session, if you remember, we did all the logics here, like insert at tail, insert at head. So I don't want to fill up my main class. I want to create a separate class, double linked list. So uh, it will have a head. So private node head. So I'm maintaining tail as well. Okay, just for the convenience. So now Okay, so now there will be one case called inserted head, int data. Okay, so this, how do I do? First thing first, I will check if my head is equal to null or not. If my head is null, that means was this is the first element. So this dot head is equal to new node 10, whatever it is data. So we have created the head, and now the tail will also point to this thing. This dot tail is equal to the head. Okay, so the first case, I'm maintaining, I'm doing a linked list with head and tail pointers. So remember this. So if it is one, so the first element, if it is one, head is also this thing, tail is also this thing. So that's why I'm making it point to the head. Okay. Else what I have to do, else that means there is a tail. So what I have to do, this dot tail dot. So I will just create a new reference. Okay, this dot tail dot next. So I'm creating a list. So something is created now. Now tail of next, I want to point this. The tail of next is equal to new node, and then new node of previous is equal to this dot tail. So as this is a double linked list, so I have to point this to this as well. So new node of previous is equal to this dot tail. This is not inserted head, this is inserted tail. And then this dot tail is equal to new node. Okay, so now we will increment the tail pointer. Tail pointer comes to this point. Yeah. So the same thing will be inserted head as well. So if my head is, so you can write that if my tail is null. If my head is null, then what you have to do? So okay, so now inserted head we will see. Okay, so let's see. So the first condition remains the same. If the head is null, that means there are no element in the list. Then what? Okay, so now the next thing that we have to do is, so first things first. So now we have to first create the link. So this dot head dot previous is equal to new node. New node of next is equal to head. Okay, and then this dot head is equal to new node. Simple. If you see here, we are setting the next, here we're setting the previous, here we're setting the new node of previous, here we're setting new node of next, because this is how my linked list will be. So here my new node of next I have to set, and then head of previous, the new node of next and head of previous, and then I'm updating the head. So as we have already seen, insertion and tail means tail will get updated, insertion and head means head will get updated. Okay, so these two methods are almost done. So now let us have a list, means print method, public void print list. So node current is equal to this dot head, while current is not equal to null. System.out.print and the end I will just print null. And here I plus plus. Okay, so this is done. And as these are getting private, so we have to expose a method. So this is public void, it's not public node get head, return this dot head. Yeah, so all my methods are done, so we will execute this thing now. So what is this name? Double linked list DLL is equal to new. Okay, so we have created. Now insert add tail, we will say 10. So let's take the input from the user itself. Okay, so this is what in dot next int. Then we have created a linked list, and now we have to insert it in dot next int, and then I'll simply print it. Okay, so let's give 1 2 3 4 5. So see 1 2 3 4 5. So for your example, we will, as this is a double, we will use this annotation because we can go both the ways. Okay, this is just for understanding or reference. Okay, so if you see, we have created our double linked list. Let's say I want to again do inserted head again for the n numbers, let's say. Then again I will give 5 4 3 2 1. Actually 1 2 3 4 5, then 1 2 3 4 5. Yeah. See. So it's working fine. Any questions in this implementation? Just go through it. These are two main things. So I'm just writing about insertion. You can also work on the deletion part. So tell me, what is the time complexity of these two methods, line number 19 and line number 31? What are the time complexities of these two function methods? Come on, guys. Time complexity of inserted tail and inserted head. Yeah, so both of them will be order of n, order of 1, because this is a constant time operation. All we are doing is changing the pointers. Okay, and print list is any order of n. I'm just sharing this logic with you. You can just go through it later. This is not coming. Just remember this class name and create your own class. So this is the class name. These are the methods. And this is the main class. Okay, if you are good, then we will start the problem solving questions. Okay, so let's start our problem solving question. So this is the first question. So you are given a number represented as linked list. That means if the number is 192, it will be given to you in this order. So 1 is a node, then 9 is a node, and then 2 is a node. So to this number, you have to add 1. So that means what? 192 plus 1 is what? 3, 9, and then what? 1. So the resultant linked list should be something like this: 1, 9, and then 3. So this should be the answer. So how will you do this problem? What is your approach and how will you do it? And it is a single linked list given to you. It will not be a double linked list. It will be a single thing. Did you get the question? Did you understand the question? Traverse till last, delete 2 and add 3. Okay, but how will you understand? So if the number is something like this, let's say think the number is like this. So in this case, we have to make it 200. So think of this case as well. If the number is 99, we have to make 100. Think of this case as well. So let me create a single linked list class similar to this thing. It will have only head. So I've created a single linked list. So it is using the same node, but we are not updating the correct previous pointer. So it is basically a single linked list. So now you have a function something like this. So the function is public static node add 1, something like this, and then the node. So you are getting a head pointer. You have to perform some operation. You have to do the +1 and you have to return the head of the this thing. So you will get head of this thing. You have to return head of this thing. How will you do it? So people are saying that just add 1 to the last. Okay, I will add 1 to last, but what about this traversal? How will I go to 9 back? And how will I go to 1 back? If there is a carry, then how will I take those 2 carries as well? Think it's a very important and a simple question, not a big complicated one. Just think of it, guys. Think of the solution. Put your answers. Only 2 members have replied, so there are 145 members. I'm expecting at least 5, 6, 10 answers. We can perform some operation manually and check the digits with the data field of the node. If not matching, then delete the node and the digit. Okay, so basically you will create the integer out of this thing, and then you will do the sum operation, and then you will parse and you will create a linked list like that. So 1, 2, 3. The first step you will convert it into integer 123, and then you will add 1. Let's say 4. Then again you will try to check with the node values and then change it. Okay, so this thing works and okay, but there is no guarantee that this integer conversion is possible, because if the linked list is very big, something like 40 digits, so we cannot hold a integer who is having 40 digits. The maximum range that we can do is what, something like, let's say 64,000 is the last limit of integer. Okay, so 65,000 number if I give you as represented as linked list, then it will not be possible. Okay, so here if you see, the main challenge of us is to how do we go till the last element, how do we add a number, and how do we carry forward the resultant reminders. Can't we use begint? You can use begint, but even begint is having some restrictions. So begint will technically have a limit, right? That they cannot have more than this integer. Whereas linked list is dynamically growing, so I can give you a linked list of 1 lakh element also. So no one is stopping me to do that. But begint will also technically have some limits. Okay, so now if you see, the only confusion or the only point here is 1 to 9, let's say. I have to go till the last element, I have to add 1, and whatever reminder is coming back. So 9 plus 1 is 10. That means this digit should be 0, and then 1 should be carry forward. Yeah, that is what we will do. Uh, so now the point here is we will go something like this. Somehow we'll go to this point, and then here we will just change it to 0, and then we will return back, and we will, whenever we are returning, we will carry forward 1. So now 2 plus 1, it will be 3. So now the remainder is 0. So now the 1 plus 0 is 0. So if you see 130. So this way of traversal we have to do. So as you know, single linked list we can only traverse in one way. So this back reversal is not possible. But if you remember, if you understand, this can be easily done with recursion. Because in recursion we will be going into recursion, and while coming back we can simply perform our operations. So here if you see 1, then we'll go to 2, then we'll go to 9, and this is the last point. So we will add 1, and whatever is there we'll send the carry, so reminder. So then it will take 2 plus 1, and then it will take 1 plus 0. So internally it will be changed to like this. So now the point is, how do we cover up this case? So 99. So 99 means, see, the recursion starts with 9. From 9 we go to another 9. From 9 we try to go there, but this is the point that it will break. So then here we have to send 1. So now 9 plus 1 is what? 0. Means 10, but so this digit will be 0. So reminder will be 1. So he will carry forward 1. And now here also it is 0. So if you see, my nodes are 0. The nodes are changed. But now even this will return 1. So whenever we are having a reminder which is not equal to 1 at the last stage or the last step, we will create a number like this and point it like this. So it will become 100. So that is how our logic will be. I will simply write this logic. Okay, so let me implement a insert.tail method. If my this if not, you have to go to the last. This is a single linked list. That's why in such a tail will take order of n with, and we are not having like a tail pointer. This will stop at last element. So current dot next is equal to we will give a new node and then return head. Okay, this we don't need. So I'm just having only one method, that is inserted tail. So even here this will be taking a head. Okay, so now we will say node now what is a single linked list. So check notice this, I'm using static methods, so I can simply use something like this. Head is equal to single linked list dot insert a tail head comma this thing. Single linked list is print list. Yeah. So this will print it, and now we have to do it. So print list of what head, and then the next step is print list of add one. For now, let me return the head only. Okay, this was all the setup. We didn't start the actual implementation. So I've just created a insert and tail and print list method for our convenience. Okay. See 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. So 1 is not getting added, so it should be 1, 2, 3, 6. So for this, as I said we will use recursion for the traversal, right? So in linked list, the back traversal is not possible. So we can easily do it with recursion. If you're not using recursion, then what you have to do, let's say 1, 2, 3 is there. So we have traveled 1, 2, 3, 4, and now we have to travel in the back way. So we can put while traversal we can push the elements 1, 2, 3, 4, and once we have 4 here, right? So this is the end. So then we will go back. So we will pop the element. So 4 is the last element, 3 is the second last, 2 is the second means third last, and then fourth last. So this will give us in reverse order. If you don't want to use recursion, this is how you have to do it using stacks. But we will use a recursion for simplicity of code. Public static int. Why int? Because we are returning a reminder. So this reminder is nothing but integer data. Public static int logic, I would say it will take the head. So the base condition of recursion is that if my head is equal to null, that means it is going beyond the range. In that case, I will return 1. So see this, whenever it is going beyond the range, that is only that is the part where I say that okay, add 1 to the number. So reminder is 1. Okay. Else, now what I have to do, I have to first calculate the reminder. Int reminder is equal to logic of head of next. So now we have to calculate the sum. Reminder plus head of data. See, reminder plus head of data. So this will give me the sum. Now head of data is equal to what? The sum per modulus 10, because if the number is something like 10, the 0 should be replaced and 1 should be carried forward, and then I will return the carry. So this is nothing but sum by 10. So if you see if a number is 29, so this 9 should be the number in the current node. So 9, how will I get 29 mod 10 will give me 9. That's why I'm head of data is equal to 9, and I have to carry forward 2. How will I get 2? 29 by 10 will give me 2.9 something, which is integer means it is 2. Okay, so that's why I'm returning this thing. Okay, so this will do for all the things recursively, and then what? And then here I have to check int reminder is equal to logic of head. So this will give me the last final reminder. So this thing, so we start the recursion from here, right? So at the very last step, we will get a reminder. So if this reminder is something else without, let's say without 1, so in this case, we have to insert it. So if my reminder is not equal to 0, we have to add some node, add node. So this is what node, new node is equal to new of reminder, and new node of next is equal to head, return new node. Simple. Okay. Else, now my reminder is 0. That means there is no number to be added. So I can just simply return my head, because head is already updated. Okay. So let's check this. See, 1, 2, 3, 4, 5, 6 is the answer. So let's give a 1, 3, 129. See, 130 is the answer. Let's give 199. 200 is the answer. Let's give 99. 100 is the answer. Okay. So this will work for all the cases. See, for 9 it is 10. So this is a very simple recursive logic. If you don't want to use recursive, if you want to use the iterative approach, you have to use stacks here. Okay, we'll learn more about stacks, how to implement stacks in the coming class. But stack is just a simple data structure with first in, first out. So it is an entry and exit controlled data structure. That means entry will happen in this point and exit will also happen in this point only. So it will maintain, due to this condition, it will maintain this order: first in, last out, or you can say last in, first out. It will have the insertion and deletion in this order. Clear with the solution, guys? Did you all understand the solution? Let's go through it once. I'm sharing the code as well. Any question, guys? So if no, we will move ahead with the next question. Just minimizing these two things. Okay. Okay, so now the next question is reverse a linked list. So it's a standard question and you also know the answer to this. So if a linked list is given to you, head pointing to single linked list again, 1, 2, 3, 4. You have to return a new head. We have to return a new head where head points to something like this: 4, 3, 2, 1. So you have to do this reversal. So how will you do this? So till now we have seen how do we so in the last session we have seen how do we print the linked list in reverse order. That means what we did here there was we went in recursion till the last element, and then while coming back we printed it. So 4, 3, 2, 1. But now this is not printing of the list in reverse, but it is actually reversing the links. So now if you see, 1 was pointing to 2 previously, but now 2 is pointing to 1. Okay, if you see, just understand these two links. So how will you reverse this list? Using double linked list? No, it's a single linked list, guys. You cannot reverse it using double linked list. Okay, using stack. Let's see if you can use stack here or not. So let's say we are traversing. So 1, 2, 3, 4 is there. Okay, so we'll pop up, push all the elements in stack, and then while coming back, we will just maintain 4 points to 3, points to 2, points to 1. Yeah, this can be done. The stack can be done. The stack is nothing but the reversal thing, means recursion thing. So we can do it. But I don't. So if I'm using stack, what is the space complexity? You're using a space complexity order of n, but I don't want to use order of n. I want to do it in constant space. So it's a standard question, guys. So I will explain you. So all you have to do is you have to do some pointer manipulation here. So let's talk about this segment of the linked list. Okay, so in this case, what I will do here is we will maintain a current pointer as usual, but there will be two more pointers. So they will be previous and they will be next. Okay, both of them was initialized like this. Okay, so the first thing that I will do is therefore it is a four-step algorithm. I just write the algorithm here so that you understand it. So the first step that I will do is I will set the next. So I will set the next to current of next. Okay, this is the first step. Then I will do what current of next is equal to. Then I will uh, update my means change the link. Okay, this is the part where I am reversing the link. Reversing the link. Okay, so now I am pointing it to the previous pointer. Now my previous should move to my current and my current should move to next. That's simple. So these are the three steps that four steps that I will follow. Okay, so see this. So this is my first step. So my first step is what I will move my next to this thing. So I will store a reference of my next pointer. So now my reversal should happen. So now my current of next, this pointer, I am removing and I'm pointing it to the previous thing. So whatever my previous is pointing to. Okay, previous is pointing to null. That's why one is pointing to null now. So now reversal is done. Now I have to move my pointers one step ahead. So now what my previous should come here and my current should be here. So current. So this will be previous and this will be current. So my previous will be here and my current will be here. So this is how my loop will end. Okay, then again the next loop, what will do, I will do my next will point to this thing. So my next will come here and then I will do the reversal. Current of next is equal to previous because previous is here, and then what previous will come here and previous is here and then current will be here. So in this way, if you see, I have reversed all my things. So at the very last step, if you see, let's do this step also. So my next will be at this point something, it is null. So current of next will be previous. So I will reverse this pointer. So previous will come here and then current will come here. So at the very last step, my previous is something that is pointing to the actual head starting. So I can simply say that after all this operation, I can simply say that head is equal to previous. Okay, so at the end of this loop, okay, my head will point to previous. So if you see 3, 2, 1, it is completely reversed. It's a standard algorithm and it's four-step algorithm. Just try to understand it. Don't remember or mugify it. So just try to understand it. So first thing that we are storing the next pointer. Okay, once we are storing the next pointer, we are updating the previous. That means we are updating the current dot next. That means this is the part where reversing is happening. Then we are incrementing the pointers. One step to identify is just whatever we put it on the left side will come on the right side. Something like this. Just a hint for you to understand. Okay, see current dot next, current dot previous. So just try to understand these 4 lines and you'll be good. So let's see how we can do it. It's a very simple logic. Public static node reverse node head. As I said, we will maintain 3 pointers. Current, it will point to head. Previous will point to null. And then next will point to null. So these are the initial steps. So there are a few sanity checks that we can do. If my head is equal to null, okay, or my head of next is equal to null, that means there is only one element. So I'll just return head. Okay, so if not, they are more than one or two, three elements. In this case, I should start my loop now. While current is not equal to null. So we have seen this statement. So if you see, my current at the last step will go to this point. That is nothing but null. While current is not equal to null, I will write this 4 steps. So the first step is what? So I will increment my next pointer. Next is equal to current dot next. Now I will update the current dot next. This is the part where I'm reversing. So it should point to the previous thing now. Reversing. So now once the previous is moved, then I will move, then I will increment the pointers. So the first pointer that I will move is previous. And then I will move current. See, remember, we cannot do current dot next like this because current dot next is changed. That's why we are first storing the next pointer. That's why we'll use next pointer. And after all these operations, my previous will point to head. I know that part. So I can simply say head is equal to previous and then return head. So this part I'm just writing for your understanding that head will be pointing to previous. You can simply return previous as well, but let's not do it so that you understand it. Okay. So, okay. So now we will do reverse head. Okay. So let's give 5, 1, 2, 3, 4, 5. See, 1, 2, 3, 4, 5. It is reverse 5, 4, 3, 2, 1. So this should not be. See, 1, 2, 3, 4, 5, which become 5, 4, 3, 2, 1. Okay, it's a very simple logic, hence, but an important one and a crucial one. Every student should know how to reverse a linked list. It's a simple, but once you understand it, it's very simple. But if you don't understand, if you try to mugify it or just remember the steps, then it will become a complicated one. Okay, so a follow-up to this question can be one more thing, that how will you solve it with recursion? Can you solve it with recursion? That is a follow-up that you can have. So here this is an iterative approach. Let's see the recursive approach. Okay, something like this. I will have removing these two lines. So in recursion also we can apply the same logic, but let's see recursion what happens. So recursion means what? We will perform the operations again and again. So let's say 1, 2, 3, 4 is there. So yeah, I am at recursion now. So the first step. So I am at 1. 1 is pointing to 2. So remember this thing. Okay. Now I'll say that, okay, you reverse the remaining part. From 2, you reverse the entire list. So what I will expect, I expect that, okay, let's not discuss this. So we are here. So 2 is pointing to 3. So we will go into recursion. Now 3 is pointing to 4. Okay. So now we will go into recursion. So this is a 4. So this is the part where I know that this is a single node, so we cannot reverse it anymore. So I will return it back. Okay, so understand this part now. So when I am coming back, this is the reverse list basically. Whatever is he is returning, it is nothing but the reversed list. So this to list I have to add it to the end. Okay, so how will I do that? So if you know, we have to return something like 4 comma 4 points to 3. Maybe this you have to return, but how will I do this? So if you see this, 3 is pointing to 4. That means I have 4's address. So 3 of next is something that we have to change. So if I just do something like this, like head of next is equal to head. Okay. If I do this, that means what? 3 of next is 4, 4 of next is something. To that something, I'm adding head. Head is nothing but 3. So this is what I'm doing here. Okay, so 3, so it's internally means 4 is pointing to 3 now. Okay, so done. So now what? So now 3 of next should also point to null. because this is the reverse part, right? So this should point to null now. So where is my head? Head is still at 3. So I will just say that 3 of next is null. That means head of next is null. Head of next is equal to null. Okay, so these two steps are important in recursion. So now 4 and this is done. So I will return this list. So he will get 4 points to 3 points to null. So now I want to add 2 to the end of 3. But how will I get access to 3? I have this 2 is initially pointing to 3 only. So when I say 2 of next of is equal to 2, this will nothing but it will make it something like this. Okay, so now 2 is added here. So now that 2, for that 2 we have to put the next as null. So with this step we can do it. And then we will return this pointer. So now it will have 4, 3, 2, okay, and then points to null. So for after 2 we have to add 1. So for that we need to go first get the access of 2. How will I get access of 2? Using this thing. So we can simply do 4, 3, 2, then 1. Okay, so this is done. But 1 is still pointing to 2. So this is kind of like this. So 1 is still pointing to 2 here. So I want to break this loop and then I will make this as null. Okay, so with this we're having a reverse list using recursion. Yeah. So kind of complicated one, but remember it's a very simple 2 lines code, but this is a background, how things are happening, how is it maintaining the links. So just understand that whenever I am starting recursion, my head is pointing to some node and that next will point to the next the node. So when I'm reversing it, so this will be the last element of the linked list. So to that last I am adding myself. Okay. Let's see the recursive logic. So this is the base condition. If my head is null or head of next is null, then return head. If not, we have seen these two lines. First I have to get the reverse list. Sorry. Is equal to reverse recursion head of next. Okay, but I'm saying that you take to the next pointer, go to next pointer and get me the reverse list. So this is expected to give me the reverse list. And then what I have to do, I have said you right. So head of next is equal to head. So this will attach itself. So it will attach itself here. But still my 1 is pointing to 2 now. If you see 1 is pointing to 2. All we did is make 2 point to 1. But still 1 is pointing to 2. So I have to break this link. So how will I get access to 1? 1 is nothing but the head. So head of next is equal to null. So once this is done, I attach myself to the last. Now do I have to return the last? No, we have to return this thing. So this is nothing but the reverse list that was returned. So I just return reverse list. So this will also work. So let's now execute this. So 1 2 3 4 5 it will be reverse 5 4 3 2 1. Again I am reversing, so it will be 1 2 3 4 5. So the output I'm talking about. Okay, 1 of null. So there is some mistake here. So uh, what is the point or what is the mistake? I will see. Mm. And so it is going to the last one. Head of next is equal to null. I don't see any mistake. Why is it pointing to only one? How is the print method implemented? So let's see this whether this is working or not. Yeah, so first time it is working, but second time when we reverse it is not working. Mhm. This is strange. First time it is working, but second time it is not working. Oh, okay, okay. So we are not storing the reverse pointer, right? So we should actually do it like this. Head is equal to. So that was a mistake. So we were not storing it. So if you remember, after this reversal, my one is pointing to null. So technically, I am still pointing. My head is still at one. This main head. So that's why it was trying to reverse only one element. So now it will work. If I give him the reverse head, it will print the reverse head. Now I will do reverse head. So now it will work. 1 2 3 4 5, getting reverse 5 4 3 2 1, and then 1 2 3 4 5. Okay. So did you understand this recursive solution? It's an important thing, guys. You should know how to reverse a linked list. Try to understand, guys. So it's a simple thing. All you have to understand is why I'm doing head of next of next. Oh, I'm doing head of next because if it is 1 4 2 2 3 4 5, okay, when I am at 1, my reverse list will be 1, and then the reverse list will be 4 3 2. Okay, so now I have to attach 1 to the end of 2. How will I get the end of 2? So I already know that 1 is pointing to 2. So now if I just do like this, so it will add it like here. Okay, head of next is equal to head. So but in this case, what is still 1 is pointing to 2. So there is a reverse link that is happening. So how to avoid this? In next line, what I am doing, my head of next is equal to null I am doing. Okay, so this will remove the link. So now I'm returning this pointer only, the reverse list head. Okay. Remember, I'm not returning head. I'm returning reverse list. So these are the two ways you can reverse the list, and both of them are important. And depending on the situation, you use either recursion or you use either iterative approach. But if the question is given to you about reverse list, always go with the iterative approach because iterative approach will always be faster than the recursion. I'm sending you these two logics. Okay. So done. Let's move on. let's discuss this question. So merge two sorted list. We are good, right? We can move ahead. Can we move ahead? Okay. So this is the next question. So next question is, you are given two sorted linked list. You have to merge them. 1, 2, 4, 9, and let's say 1, 2, 5, 2, 3, 5, 6. Okay, so this is the two linked list. You have to merge these two linked lists and you have to return a new head, which is a sorted thing. So 1, 2, 2, 3, then 4, 5, 6, and then 9. Okay, you have to do this. How will you do this? So let me give you a function definition. A static node head 1 and then node head 2. So you have to do this. So tell me, how will you solve this? What is your approach? What will you do based on how you will do the pointer manipulations? Come on, guys, think. How will you do? At least think of something. Will you traverse the first list first and then will you traverse the second list, or you will do insertion at index? What is the case? How will you solve this? So we know how to insert something in the linked list, how to insert a number in the sorted linked list. We have seen it in last class. Insert a node in sorted linked list. Yeah, we have seen it in last class. So how will you use that logic and how will you at least try to think in that sense? So we are in the last class, we have seen this question. In the last class, we have seen this: insert a node in sorted linked list. So now we are we try to use that logic here. At least try to think in that sense. Yeah. Okay. We can use 2 pointer to compare the two lists, correct? So out of 157 members, only 1% thought of an approach and gave the answer in the chat. What about the rest? So it is a very simple logic, guys. If you understand the previous solution, this question, so at least you could have thought of this thing. So we will take this element, we will insert into it this node. So it will be 1, 2, 2, and then 4, then 9. So this will be done in first go. Okay, then we will take this one and then we will insert in this thing. So it will be 1. So we have already seen how to insert an element in the sorted linked list. 4, then 9. Then again we'll insert, then again we'll insert 6. So this way we can do it. So you could have at least thought of this approach. We will insert in them in one go, but I'm just saying that we could have thought of this approach at least. This is the simplest thing to think of. So this approach, if you see, this is having a time complexity of, so if you are having 2, then this might travel n times, then this might travel n times, then travel n times. So this will grow n, so till n times. So this is nothing but n into n. So this is not good because we are traveling our linked list many number of times. So this becomes n square. Though I would still appreciate this approach if you would have thought of, but no one, only apart from one person. Okay, so this is not a reliable solution. So we have to think of any other solution. So let me copy this thing. Okay, so this is the linked list. So what we will do is we'll maintain 2 pointers. One is head 1 and one is head 2. We all know this. This is already given to us. Then we will compare these two elements. So which one is smaller? One is smaller. So we will we will just keep 1 here in the resultant answer, and then 1 should point to the, so in recursion or whatever it is, so we will now move our pointers here. So 1 is done. So now I will move our pointer to 2. So now both are same, so I can move any one of them. So let's say I move this thing. Okay, now 2 and 4, which one is small? 2 is small. So 2, and then it will move ahead here. So it will be pointing to this thing. So now 4 and 3, which one is small? 3. So now this will be moving here. So 4 and 5, which one is small? 4. So on, by based on one pointer incrementation, we can do it. So if you see this, so it will become 5, then again 6, then again 9. So this is a simpler way. So this is not exactly the same way how we did the merging of two sorted arrays. So if we have 1, 2, 3, and then we have 1, 3, 4. Where in merge sort, if you remember, we created we created an array. We have 2 pointers. So which one is small? We were adding it here. So this 1 is added, then another 1 will be added, then 2 will be added, 2 and 3, where 2 will be added, then 3 will be added, then 3 will be added. So if you see, we are incrementing the pointers one by one, one by one. So same logic is here. So based on the comparison, we will increment the pointers. So the time complexity of this approach will be how much? To traverse this, it will be n, and to traverse this, it will be n. And we are doing only traversal only one time. So it will be n plus n. This is nothing but order of n solution. Okay, so you should do it in this way. So let me write the logic so that you understand it. So I will write a recursive logic. You can do it with iterative also, but you have to be very careful with the pointers. So I'm just writing a recursive logic so that it's easy to write. If head 1 is equal to null, that means there is no node linked list 1. So I'll just return whatever the value is there in the head 2. Else if head 2 is equal to null, that means head 2 is null. Okay, so in this case, I'll just simply return whatever the value is there in head 1. Okay. Now when I'm reaching this point, that means both the nodes are having some value. So now I have to check if my head 1 dot data is less than or equal to head 2 dot data. Okay. In this case, head 1 dot next is equal to, so I'll proceed with head 1 now. So I will just make sure that head 1 is here, that means 1. So when I write this, it is not actually creating a new linked list. So I am just manipulating the pointers. So I am saying that, okay, stay to this one, the next pointer should point to the winner of these two linked lists, so this linked list and this linked list. Okay, so that's in recursion I have to do. So in recursion, so I'll stay at the head 1. Now the next pointer will be the sorted linked list of the pointers, so the remaining lists. So the what is the remaining list? I will increment head 1 dot next, and I'll stay at head 2 only, then return head 1. Okay, so this is a simple thing. So when I do this, so I will explain you again. 1 comma 2 comma 3, and then 1 comma 3 comma 5. So 1 and 1 I am comparing. So this matches. So when I say 1 points to this, so what I am doing is I'm still here. So head 1 of this 1 points to the winner or the merge list of these two things. This entire thing basically. So this is the part where I'm doing it. So next is equal to merge list of then remaining list. So remaining list is what? So as head 1 is already taken, I'm incrementing head 1, and head 2 is still at that point only. So see this, head 1 is already here, and then head 2 is already there, head 1 is incremented. Else what I have to do, head 2 dot next is equal to, now I will increment head 2 and head 1 will stay there because head 2's value is next, smaller. And then return head 2. Simple. So this recursive logic will go list by list or node by node, and it will just compare and update the pointers. Okay, so let's comment out these many lines. Head 1 is equal to null. Head 2 is equal to null. Okay, now we will have so n is equal to, so head 1 is equal to single linked list inserted tail. Now head 2 is equal to, okay, now I have head 1 and head 2. So now I will say, let me first print them. So can simply say print both my things, head 1, head 2. And now print the merged thing. So merge head 1 comma head 2. Okay, output is not given. Let's give 5, 1, 3, 6, 9, 10. And let's say 4. It is 1, 2, 4, 5. Okay. See this 1, 3, 6, 9, 10. This is the first list, and then this is the second list 1, 2, 4, 5. And then after merging, it is 1, 1, 2, 3, 4, 5, 6, 9, 10. So it is merged. So both the two, this is sorted and this is sorted. So these two sorted linked lists are merged to one thing. Clear everyone with this approach? This is a recursive approach where we are just updating the next pointer. If you are doing it in a iterative approach, you'll have to be very careful with the pointers. So in recursive approach also you have to be, in iterative approach you can also do maintaining a while loop or something like this. So if you remember, let me write, you can write something like this, while current one is not equal to null and current 2 is not equal to null. So this is the part where you have to do some checks. So checking and updating the link. Okay, So now they have to check the also two loops. So if you, this is again similar to the merge sort to while loops, if you remember. So if one of the linked list is null, then we have to paste the remaining linked list. So if my current uh, is not equal to null, that means there is some elements remain here, means remaining here. So while loop is not required here. If loop can be done, then we have to say like answer dot next is equal to. I'm just trying to write a pseudocode. Else if current 2 is not equal to null, so that means current 2 was not exhausted. So like this. So some kind of link like this. So this will work for iterative way, and recursive way is this thing. So it is an important question, guys, merging two sorted linked list. So you have to be careful with the pointer operation. So when you are changing or swapping pointers, be very careful in that. I'm sharing a logic with you. Just go through it. Okay, so the next question, can we move to the next question? Okay, so the next question is also important. The next question is sorting a linked list. So you are given a linked list, you have to sort it. So how will you sort a linked list? So in arrays, we have seen bubble sort, merge sort, quick sort, selection, insertion. But linked list, how will you sort it? So one, two, let's say a linked list in this is a linked list 3, 2, 1, 5, 6. Okay, you have to sort it. So the resultant answer should be 1, 2, 3, 5, 6. So this should be the answer. How will you do this, and which sorting algorithm will you implement? So let's say there is some like this public static node sort node head. Okay, tell me guys, how will you sort a linked list? So which sorting algorithm will you implement? So what are sorting algorithms that we know? Think of that. We know bubble sort, we know merge sort, we know quick sort, we know insertion and this thing selection. So in bubble, we are again checking the adjacent index. So I comma j, I comma j, I comma j. So bubble sort could be done, but insertion sort, if you see, we are taking an element and then we are going backwards and putting in the correct place. So going backwards and traversing back using ij indexes is not possible in linked list. So insertion sort cannot be done. Selection sort also cannot be done. So selection sort, if you see, you can try out, but it will be very complicated because you have to remove it from that position and put it in the beginning. So you can try out. Just think which sorting algorithm will be very much efficient for linked list. Quicksort, can we do quicksort for linked list? Can we select a pivot index and now can we do in that sense? Okay, only two answers in the chat. Remaining people, what is happening with you? So let's see the logic. So if you understand linked list properly, if you see, we cannot traverse back, we cannot do the random these things and all. So pivot, if you see, if you're taking quick sort, so in order to get the pivot, I have to go till this element, the last element, and then if I want to place it, that means what? I have to again do some insertion and middle. For insertion middle, again I have to do something. So it's becoming very complex. Either you have to maintain this or something like that. So it's very complex to use quick sort, any other sorting algorithm apart from merge sort. So merge sort is simple enough because we are just dividing our linked list into halves and then sorting the two halves, so that we have already seen just now. So we can just simply do it. So we will divide it into two halves. So let's say we divide it into 3, 2 points to null, and then 1, 5, 6 points to null. Okay, and then we will point 3 and then 2. This is 1, then 5, 6, then 5, and then 6. So merge sort. So merge sort you already know. So we are dividing the linked list into smaller parts. So when we are here, so this is a sorted list and this is a sorted list. So we have just seen how to merge two sorted lists. So we will simply merge two sorted lists. And then here also we will merge two sorted lists. So 5, 6. So even now, if you see, this one is a sorted list and then 5, 6 is sorted. So I will simply use the same logic, merging of two sorted lists. So it will be 1, 5, and then 6. Finally, these two are sorted. So this is a sorted list and this is a sorted list. So how will I merge two sorted lists? We know the logic. We know the logic. So it will be simple. 5 and this 6. Simple. So the most efficient way for solving a problem, sorting a linked list would be merge sort. So that's why we will use this. And space complexity of merge sort for linked list is order of 1 because we are not storing any temporary variables. So in arrays, we use temporary arrays to store it. That's why the space was order of n. But here it will not be order of n because we are just reusing our own node. So we are not creating anything. All we are doing is breaking and then merging two linked lists. So merging of two linked lists, we are not creating any extra set of memory. This is the part, right? So merging, we are not creating an extra memory. So it is order of 1 space complexity, and time complexity, you all know it is order of n log n. So let's see how we can do this. So recollect merge sort, guys. What is the first step that we do in merge sort? Tell me. I won't start until unless you tell me. What is the first step that we do in sorted merge sort? In arrays, in merge sort, what is the first step that we do? Okay, dividing. How do we divide? On what basis do we divide? Yeah, splitting the list from midpoint. So basically, we have to find the mid element. So how do we find the middle element? So we have seen this question in the previous class as well. So to find the middle element, you can either find the length and then go n by 2 times, or there is one more way that we have seen is that slow and fast pointer approach. We can use any one of this and get the middle point. So once the middle point is there, we will divide our list into two halves. How do I say that I divide? So I will just make mid of next is equal to null. So this is breaking the link. That means these two are divided. So once it is divided, we will sort these two particular halves. And once these are solved, then we will merge it. Simple. So now I will say the first step is that again a sanity check if my head is equal to null or my head of next is equal to null, return head. Okay, so these are the base condition for my recursive logic. And now the next step is I have to find the mid. So mid is equal to get middle. Let me write it like this. We have seen how to find the middle element, public static. So that middle element we'll use now, public static node. So there are two approaches we have discussed this here yesterday. That first approach, find the length, then find the mid, then go till the mid and divide it from there. Or we can use the slow and fast pointer approach. So node slow head, node fast is equal to head, while fast and fast of next null, fast of next of next. Okay, so this is the point where I will do the incrementation, pointer incrementation. So fast runs at 2 speed, so fast. So the main intention or why we are doing this slow and fast pointer is we want to get the middle element in order of n by 2. So if you are doing it with a length and then going till n by 2, so it is n plus n by 2. Technically, they are still the same. But if you see if my linked list is of 1 lakh nodes, so the first approach will iterate 1.5 lakhs time. But whereas this approach will iterate only 50,000 times. So that's the difference. Though the time complexity may not be that different, but I'm just giving you a real time example. And then we know that slope will be pointing to the middle element. Yeah, so middle element is found. Okay, so now what I have to do? So I'm just storing the next pointer. So why do I store this next pointer? Why? Because I will break the link. So now mid of next is equal to null. So that's why I am storing it before. So if I don't store it, I won't get the second half, starting of the second half. So to store the starting of the second half, I have created this variable mid next. Okay. So now I have to recursively sort it. So left is equal to sort my left array. So my left array is nothing but this thing. Sort my right array. So my right array is nothing but starting at mid next. Simple. So this is assumed that my left and right will be sorted and it is given to and it will be given to me. So I can simply merge my sorted lists. So what is the sorted list? So first is the left and then it is right. Okay, just merge it and return it. Simple. So this will solve, this will recursively go, divide the list into smaller parts and then merge them recursively. See, 1, 2, 3, 4, 5, 6. If I give him 6 and something here, let's say 4. So 1, 2, 3, 4, 5, 6. Okay, so this is the merge sort logic. I'm giving the solution to you. And just for reference, the middle logic that we have seen. So if you see, if you notice here, we never touched this logic because we need not to do this because this was implemented properly. So this was about merging two sorted linked lists. So we are reusing this thing. That's it. Any doubts or any questions? So we have seen linked list, we have seen reversal of a linked list, we have seen sorting of a linked list. These are two very important operations of linked list. And then arrays also we have seen both searching and sorting. And other problem statements also we have seen. So with this, like we should be okay with the linear data structures like arrays and linked lists. So no matter what the problem is given to us, we can either sort it, we can either search it, and we can do whatever operations we want. So we should be in that stage at least by now. Any questions, guys? So the participation is very low. The engagement is very low. Only 2-3 members are replying. Okay, so let's take the another problem. Okay, so the another problem, check whether a loop exists. So it's a algorithm basically. We are only left with 12 minutes. Let's not take this because it will take some time. Let's do this thing. Adding two numbers represented in the list. So this is the next question. Adding two numbers represented in a list. So we have just seen how do we add one to the linked list. So plus one will give us some 1, 2, 3, 4, 1, 2, 4. We have seen this thing. Okay, adding one to the number. But now there are two numbers. That means it is given like this: 1, 2, 3, and then the next number could be 3, 3, 4. So basically this is nothing but 1, 2, 3, 4 plus 3, 4. So the answer should be 1, 2, 6, 4. This should be the answer. 6, 8. How will you solve this question? So here it is not a simple number. It is the number that again that is also a linked list. Try to think of this thing. How will you do that? Try to uh, think of a logic. So what will you do? So these two numbers can be of different lengths. So what should be your first list? What should be your second list? How will you do the additions? You cannot convert them to integers. These are like not a mature solutions. Converting you are given a linked list for many reasons because this list cannot be converted to a number. So this list can have a digits like 1 lakh digits it can have. So you cannot have a number that holds 1 lakh digits. That is not possible. So that's why they have given you in linked list format. So converting to an integer is not a feasible solution. So what is the other approaches? Try to think in this way only, guys. So see, so in school we do all our operations like this. correct. So we start from the back and then we will add the values. So just try to think how do we go to back of both the lists and then we still come then we do the addition. So even in the previous question we did the same thing, right? So we went till the last and then where we added one. But now here we have to not only add one but also we have to just check the next element. So this last and this last, this second last and this second last. And here there is nothing. So it will be only two and it will be only one. So how do I maintain this order? So I have to skip this many elements first. So how will I do it? Stack. Okay, let's see stack if we can do. If it is 1, 2, 3, 4, and then 3, 4. Yes, we can use stack. So let's say we have added 1, 2, 3, 4. So this is pushed and then this is pushed 3 and 4. Okay, and then we'll just pop the elements. So it is 4 plus 4, 8. But how will you do? You have to do insertion at tail then. Insertion at head basically. Then 3 plus 3, 6. Then there is nothing. So it will be 2 and then it will be 1. So yeah, stack can be done, but you have to be very careful in this insertion part, insertion order. So let's see the solution using stacks only we will do. So there is a recursive way also. You can use the recursive way as well. But as the chat is saying that we have to do it with stack, let's do with chat. Let's do with stack only. Public static node add two numbers. Add two. Okay, so this is done. So let's uncomment this. So this should give me the addition of two numbers. Okay, so what are my two numbers? The first number is the 4 digits, 1, 2, 1, 2, 4, and 9, let's say. And then the second number is of 2 digits, it is 1, 2. Or let's say 2, 5. Yeah, let's do it in this way. So for now, I'm just returning return head 1. I'm just checking whether the inputs are correct or not. Yeah, so 1, 2, 3, 4. So now we will maintain two stacks as suggested. So we will create a stack. So before that, we will import stack. Again, stack I wanted to avoid because we have not discussed stack properly. So few of you might not know about stack. But stack is a simple data structure, first in, first out. Sorry, first in, last out. So what will the stack hold? It will hold the nodes. Stack 1. Okay, so this is done. So now I have to do something like this. Head 1, sorry, node while current one is not equal to null. So before that also we can just do the sanity checks. This, if any one of the number is null, then that means no need of adding, just return the other number. Okay. Stack dot push current one. Okay, and the same thing goes with current 2. So I'm pushing all the elements. So I will travel through this thing. So I will push all the elements. So it will be 1, 2, 3, 4, and then I'll traverse through all this element and then I will push 3 and 4. So now this is the time I have to pop the elements. So how will I pop it is, so while stack 1 is not empty, I have to pop both elements from both the stacks, correct? And stack 2 is not empty. So this is the part where I will pop the element. So it will be what? Um, so now I have to maintain an answer also. So node answer. So now first I have to get the sum basically, and then I have to maintain a reminder as well. So int sum int reminder is equal to 0. So now how to get the sum is int sum is equal to stack1 dot pop node 2 is equal to stack2 dot pops. So now it will get the two nodes. So now I have to get the sum. Int sum is equal to n1 dot data plus n2 dot data plus the reminder or the previous reminder that we have. Okay, so this will have the sum, and now I have to answer means put the number in maintain the answer. So let's say this is 4 plus 4 we have got 8. So now there should be a node that is 8. So I will just maintain int answer head. So if my answer is equal to null, okay, that means this is the first element that I'm inserting. Else node new node answer is equal to new node of sum percentile 10, again the same logic, and then reminder is equal to sum by 10. If not, answer dot next is equal, sorry, we have to create a new node, node new node is nothing but sum percentile 10. Okay, and now new node of next is equal to answer, and then answer is equal to new node. So if you see, we are doing insertion at head. That means my answer point is getting changed everywhere. So that means I don't need this null check also. Even in the first case, if it is null, all we are doing is next is pointing to null and then this. So this is not required. So let's only this step is required basically. So that I will do it like this. And then reminder. Yeah. So reminder. So this loop will continue till any one of the stack is empty. So now if we have to check while stack 1 is not empty, that means we are checking if my stack 1 is not empty. So in this case, I have to do the same thing, but only with the stack 1. So n2 will be gone, and here n2 will be gone. And then same thing with stack 2. So there is a chance that, right? So one list is done, but the second list is not done. So this is the cases for them. And the same logic, this is how you have to do the merging of linked list also, merging of two sorted linked list. So you have to do the same way. Okay, it is stack 2, and yeah, so everything is clear. So now there is one more thing. If my reminder is not equal to 0, that means I have to do one more step. This is nothing but reminder. Yeah, and at the end, this will be the answer. So let's see if it works or not. Reminder. Okay, kind of going into infinite loop. Out of memory, heap space is going too huge. So yeah, so see this, we are pushing, but we are not doing current one of next. Okay, and then we will do current two of next. See, so 120, 1249, so 9 plus 4 is how much? So this is what? So 177 line, it is head 1 or head 2? Sorry, head 2. Yeah. So 9 plus 4 is 3. So 13 is here, and then here there will be 1. So let's see this 1249. 1249 plus 224. 1273. Yeah, see 1273 is there. Let's make it as 9 comma 9 and then 9. So in this case, we will have a bigger number. Okay, so 99 plus 99, it will be 198. Let's test it. 198. Okay, so logic is working fine. So did you get this solution? How did we do it? So first of all, we put all the elements in stack, and then based on the, once the stack is full, we will just pop the elements. 2, 4 and 4, 8, and then 3 and 3, 6. And then, so this is done. So now we have to pop all the elements. So 2 and then 1. Okay, so this is how we are doing it. So pushing all the elements in stack and coming and popping all the elements from the stack. So this way the space complexity is actually order of n because we are maintaining a stack to store the elements. But the actual solution that I wanted to share you is using recursion, where the space complexity is order of 1 and time complexity is order of n only. So here the space complexity is order of n. The time complexity is how much? 1. It is how much? It is actually 2n. So first time we are pushing all the elements in stack, and then we are putting all the elements from the stack. So this is 2n, but technically it's also 1. So but there is a huge difference in space. So how we can do it? So first thing, I will explain you the logic. You try to do it in recursion and you try to solve it. So first thing is that we maintain that head 1 is always the bigger number. That means head 1 is always the number which is having more number of digits. So that we have to finalize. So 1, 2, 3, 4, let's say. So somehow we have finalized. So if the input is given where head 1 is less than head 2, means the length, then we will just swap the pointers. So we will make sure that head 1 is always greater than head 2. Why? Because the solution is something like this. Then head 2 is let's say 3 and 4. So in this case, now we all know how do we do recursion. So we start our recursion and we go. But in this case, we have to skip the first two pointer incrementations. Okay, we do this head 2 of next, right? So if you see in recursion, where is the recursion? So sorted linked list, yeah. So see this, we are incrementing a pointer something like this. So for the second list, we have to skip it for these many number of times. Okay. So that you have to calculate. So that you can easily do, you have to get the head length and you have to get the head length. So 2. So 4 minus 2 is 2. That means the first 2 steps I have to skip. So once skipped, then we will do the pointer incrementation. So in recursion, it will be something like this. It will be pointing to null. It will be pointing to null. And then it will be pointing to 3 and 3 and then 4 and 4. So once it is something like this, if I can frame my recursion order in this way, then I can simply do the same logic that we have seen in the first solution. So 4 plus 4 is 8, and whatever the carries will carry forward, and then it will just add. So this addition, how is it space efficient is, we will update the head 1. So we will modify head 1 and then we'll return head 1 only. So in that case, we need not to create first of all, we need not to create new nodes that we are doing here. See this, for everything we are creating a new node, so that is not required. And also we are not storing any space. So we are not storing any space, so it will be order of 1. Okay, try this approach. It is in recursion. So the first trick is that you have to skip these two executions. So these two you have to skip and then you have to continue. So try it out on your own. If not, you can. This stack approach is also good. So it's not that it will fail or it will not work. So everyone clear with this problem? So maintain two stacks, fill all the stacks, then get the elements from the stack. If any one of them is complete, it will break. So we will just, this is meant for the remaining elements, stack elements. And then this is the extra case where one digit will be added extra. Okay, and then return answer. I'm sharing you this logic. Let's try to go through it. Okay, the entire logic is not coming. So I'm sharing in parts, guys. Remember this. Let's do till the first while loop. And then this is the second while loop. Yeah, so I've shared the logic. Just go through it one more time. Okay, so with this, we complete our linked list sessions more or less. There are a few problems that are important. We will take it up in next sessions. So next session will be on stack. What is stack? How to implement stack? Time complexity of stack, and all the stuff we will discuss, and few problem statements on stack also. So by this point, guys, you have to be very good with the linked list arrays concepts. So you have to be good with the traversal parts, recursion parts, using of the normal for loop, while loops and all. Okay, if you're not good in that, that means you need to practice. So just check yourself, where do you stand. If you need practice, just then practice, because coming sessions will be the advanced sessions. So we will start stacks, then queues, then binary tree and all the stuff. So for that, I will be assuming that you all know the traversal recursions and all. So just practice if you're not good. If not, just let us know. If you have any doubts, we can take it up sometime later. Okay. Okay, guys, so let's we can finish the session. Just let me know whether you're following or not, because the engagement was very less today. Only 5 or 4 members were replying. Okay. Okay, sir. Oh, okay then. Then we will finish the session. Thanks, guys. Thanks for joining. Next session will stack. We will start stack data structure. Okay. Thank you all then. Bye.